Hello everyone. Right. Where encoder connected? Yeah. No, it's fine. It's fine. Okay. Hello everyone. Welcome to Legacy IAS. So we are in this discussion to see our science and tech 4 questions that have come from science and tech portion in GS3. So these were the 4 questions that came. Okay. Now in these, if you see this first question, which was a little absurd in the way that it is asking that how is biotechnology being used by farmers in processing their perishable crops. So Indian farmers are using it, that is the claim. Now most of the answers that you will find on the internet using LLMs or any website also, you will find it that they are going too much into something like antisense RNAs, okay, or pectinase. All those are actually not needed because it is asking a very contextual question. Okay, so we will see this and the other things which are mostly related to current affairs, that also we will try to cover. Let's see the answers. First, understanding this, which is explained by giving 2 examples. There is a reason that they have asked for 2 examples because they also know that you won't be knowing a lot here. So basically, explain by giving 2 examples how biotechnology has helped the Indian farmers in processing their perishable crops. Now, what is a perishable crop? Perishable crops like fruits, vegetable crops which will only stay for a very short duration. After that, they tend to go bad. Correct? So those crops, how Indian farmers are using biotechnology to protect them. That is the question. So all those things, all those scientific things, okay, like antisense RNA, this, that is not actually needed. That those are still in the pipeline kind of things. Okay, that has been shown to show certain impacts. So basically, first thing, how you should introduce this is by the issue that perishable crop has, which is in India 15 to 20% of our crop produce is lost, is wasted every year. Why? Because it tends to go bad. So this should be your introduction. Correct? Then after that, how you connect it? So then the heading that you put is biotechnology interventions. Possible biotechnology interventions to prevent this. Okay, so this can be your first heading, and here you will be giving only 2 examples and you try to explain those examples. Don't give 3, 4, 5 short examples here and there. It is saying you specifically explain by giving 2 examples. So use 2 examples. Now, the first example that you can use, that you would know also generally, maybe might not have striked you in the exam, is actually of something that we call as fermentation. A better version of it you can call on-farm fermentation. This is actually used by Indian farmers. Okay, so what you have to do, let's say there are different kinds of crops that we grow. Now those crops can only stay for a very short time. So what you do, fermentation you anyway understand. So basically what we do here is by using certain lactobacillus species. These are certain good bacteria. So using these good bacteria, we try, or the Indian farmers try to break it down into simple compounds, which this bacteria does. Now this bacteria, while breaking it down, also does something, that it releases something known as lactic acid. Now what this lactic acid will do, it will reduce the pH. It will reduce the pH of your produce, and because of that, what will happen? The bad bacteria or microbes, correct? For example, E. coli you can give as an example here. This won't be able to grow on the produce. Isn't this also biotechnology? What is biotechnology? Using biological resources, that itself becomes biotechnology. So this is something that is being done by them. Example, if you know, then it's good. So example are, there is something known as Kundruk. Okay, this is from Sikkim, where what they do, basically this is very famous in Northeast. They take all their green leafy vegetables, even farm produce, even animal produce, all that they take and they ferment it, and then they eat fermented food. That is also good for health, and also it saves those, for example, green leafy vegetable have a very short life, but it can stay for a very long duration if you ferment it like this. So this is for green leafy vegetables. Similarly, in Assam it is done for bamboo shoots. Okay, so all those can be examples of it. This is the first thing that we should be writing. Then, what is the next thing that you can mention here? This is first example. Second example, this can be of simple words you can use is biopolymer coating. Now, this is also used by Indian farmers. Okay, so what is biopolymer coating? So what you do, if you have a produce, for example, if you have mango or you have apple, okay, these are some high value crops. Now, once you have taken them out, what you can do is basically you can spray a biopolymer over it. Example of this is, the most famous example is cytosan. So what you can do, you can spray this biopolymer. Now what happens? This biopolymer has a tendency to form cross links. It will form cross links and it will create a semi-permeable membrane around your fruits. Now, this semi-permeable membrane does two things. Okay, first thing, that it reduces the supply or cuts the supply of oxygen to it, because oxidation is what causes ripening, and the other thing is that it reduces the release of ethylene, which is the ripening hormone for all these fruits. Now, if both of these are stopped, what will happen? It will lead to increase in shelf life of these fruits, and then these can stay for a very long time. Okay, example of this is many of the very high value varieties. For example, Hafus mangoes. For example, apples that come from certain parts of Himachal and Kashmir. All these can be saved using biopolymer coatings. These are two examples. You can draw it in flowchart form so that you are explaining it well. Also, because this is a 10 marker, so I am using the flowchart only. Okay, that you can use in the exam also. You draw a flowchart, explain this, give some example, and that will be it. Okay, and what is the next part? I think this is the main part of the question. Then it asks you, so explain by giving two examples how this can help in processing their perishable crops. Now, here what you can mention is basically in the conclusion, you can mention like a summary, because this is a very similar question. So what you can mention, that these traditional, because fermentation, for example, is a very traditional technique. This traditional and modern biotechnology tools can help prevent spoilage of crops post harvest and prevent panic selling. Panic selling is a term that we use in economy, basically because these are perishable goods, so farmers have no choice but to sell them in panic, because otherwise they will go bad. So these can prevent those conditions. So this is a simple conclusion. Why I am mentioning traditional and modern biotechnology? To be very clear that why I have mentioned fermentation and all. This is the answer that I would expect, that UPSC is expecting from you. Not all those RNA, this, that, because all those are still in the pipeline. This is something that was very clearly asked, that which of these techniques are being used by the farmers. That has helped, that has helped the Indian farmers in processing their perishable crops. And that is why this is our answer. Now, let's go second. This is about Distinguish between a fast breeder reactor and a thermal nuclear reactor. Okay. In the context of first indigenously developed prototype FBR at Kalpakkam, explain the term criticality. Okay. So this was a lot in news. Correct. That we have achieved the second stage of Homi Jahangir Bhabha's nuclear plant. Correct. That was about fast breeder reactors. Same thing is being asked here, but the question, because it is from science and tech, it is more technical in nature. Okay, so it talks about that you have to explain criticality also. You have to explain the difference between a fast breeder reactor and a thermal nuclear reactor. Okay, some students actually got confused because of this thermal nuclear reactor. This is the normal nuclear reactor that you have. Okay, these are the simple neutrons, the slowed down version of nuclear reactors that you learn about. That is itself thermal nuclear reactor. Now, so this we have to explain first, distinguish, then explain criticality, and then the implications. Implications is something that is general and that most people would be able to write. Now, let's see. So first thing, what should be the introduction? See, here in the main body of the question, we won't be talking about that three-stage plan that Homi Jahangir Bhabha envisioned, correct? So this I can use in the introduction. So I write here, conceptualized by Dr. Homi Bhabha, fast breeder reactors, fast breeder reactor, in bracket I will mention FBR, so that I can now. Next thing is basically now I have to distinguish between a fast breeder reactor and a thermal nuclear reactor. Now, if you see here, fast breeder reactor and a thermal reactor. Now, on what basis can I differentiate them? Now, there are 2-3 things that you need to understand here, then you will be able to write it very easily. So what happens? In a normal thermal reactor, what is actually done with respect to neutrons? So with respect to neutrons, here the neutrons are slowed down by moderators. In most cases, the moderator that is used is D2O. Okay, that is heavy water or plain water. So moderators are used to get slowed down neutrons. So these are, here we use slowed down neutrons. Here, why it is called fast breeder reactor? Because the first word fast is explained by here the neutrons are not slowed down. Then next thing, fast you understood. Now we will try to understand this breeder also. So first you understand what is the fuel being used, then we will understand the fuel balance also. What is the fuel that is being used here? So in this case, that is the thermal reactors, we usually use uranium-235, that is enriched uranium. Okay, in this case what we use is basically mixed oxide of plutonium and uranium-238. Okay, this is the fuel. Now fuel balance is what gives this feature of breeder. So what happens, because here there is a constant reaction that goes something like this. Okay, reaction you can mention on the side if you want. So basically this is the reaction, 238 plus 1 neutron, this leads to formation of plutonium-239. It is good if you mention this on the side. Okay, if you remember this, so basically I am adding 1 neutron and that is getting added here, it becomes plutonium-239. Then if this is so, don't you think that over time plutonium is a fissile material, correct? This uranium-238 is only a fertile material. So constantly as plutonium breaks down, it will release 3 neutrons, correct? Neutron. Now these neutrons can attack this uranium-238 and convert this into plutonium again. And that is why more and more plutonium will be formed as the reaction goes on. That is why what will be the fuel balance? Whatever you started with, you will have more fuel or more fissile material as reaction proceeds. in this case what you will have? The normal case, that is more and more of your fissile material will be consumed. So here fissile material is consumed as the reaction goes on, and that is why what you have here is more fissile material, that is it is breeding fissile material, that's why it is called breeder reactor. So fast breeder I have explained. Now you can put 1-2 more points, because in mains you have to put them, that is you can put the what is the moderator and what is the coolant. Then you can also mention the stage, that is in which stage of our nuclear plan it is used. Okay, so this is the stage 1, correct? This is the stage 1, mainly using pressurized heavy water reactors, thermal reactors. Okay, thermal nuclear reactors. Now this is the as it is given in the question also, this is stage 2. Then what is the moderator? So in this case the moderator is usually D2 or even water, heavy water or normal water. In this case we want fast neutrons only, so we don't want moderator which slows down the neutron. So there is no moderator, there is only a coolant, and that is liquid sodium. In this case same thing is also used as a coolant, because D2 or H2O are both moderator and coolant. So this is the difference between, if you make it like this, you will create a difference in this question. This is not like some topics like ethics where the differential that you can create is very little. Okay, in a question that everybody knows. Okay, overall in the paper you can create a lot of difference, but in one particular question it is difficult. But in science and tech question, because most people go wayward, just by reading the answer for the first 30 seconds I can tell that this person has what kind of understanding of science. Okay, and that they also are able to gauge then. So this is the introduction and the difference between these two things. Then you have to explain criticality. Okay, now criticality, what is criticality? Criticality is when number of extra neutrons generated in a nuclear reaction is equal to number of neutrons absorbed or lost. Why this has to be equal? So that here you can mention the definition, the traditional definition, which is criticality is the stage in which a nuclear reactor can sustain a chain reaction, sustain a controlled chain reaction. Controlled is also very important. Controlled chain reaction. Why controlled is important? See, there is something known as subcritical, that there is something known as supercritical. Now, the problem with subcritical is that after a point neutrons will fade away. Okay, while the problem with when you have more neutrons, then it can lead to cascading effect. It can act like a bomb. So both of these has to be avoided. Now, when a nuclear reactor is able to avoid both the situations, then it is called that it has achieved criticality. Okay, now here if you have time, instead of this, what I would have done is basically I would have made this diagram, very easy diagram. So what I do, here I have a neutron. This neutron I am bombarding on this fissile material. In this case it is plutonium, or it can be any fissile material. This will lead to formation of 2 stable atoms. Now after that it will also lead to formation of 3 neutrons. So this will be neutron 1, neutron 2, neutron 3. Let's call this also neutron 1. So what I want the excess neutrons that are being generated are actually absorbed or lost, so that I have only one neutron that is carrying out the reaction in a controlled way. So what I will have is these two, I want that they are either absorbed by control rods or they are lost in core. So basically they are not part of the reaction anymore for these two, and this will carry on the sustained reaction. This is what criticality looks like. If instead of this, if you draw this, of course you will get more marks. Any one of them is fine. This also works. So this is explaining criticality, and the last thing was asking us a very simple thing, which is what this actually means. Okay, so what are the implications for clean energy future because of this? So what are the implications for clean energy future? So this is implications for clean energy future in India. So what are the implications? First thing that should come to your mind is basically waste minimization. Why? Because if you know about the 3-stage nuclear plant, okay, by homie Jahangir Bhabha, in that what used to happen? Plutonium-239 used to be created as a radioactive byproduct that was not being used for anything. So that is waste minimization, because now plutonium-239 from stage 1 will be used in stage 2 or an FPR. Even if you mention it like this, don't try to detail it, because this is a 10 marker. If you write like this, anybody who is checking your answer knows these things. So he would know that plutonium-239 stage 1 he understand, then it can be used in stage 2, or you can mention used in fast breeder reactor. That's it, FBR. It's a good enough explanation. Then next thing is basically this is a form of clean energy, because there is no greenhouse emissions or very less greenhouse emissions that you can see from this. Then if this succeeds, then India will be able to use thorium. So this is an intermediate stage, because the third stage will be mostly based on thorium. So thorium, here you can again mention that India has 25% of global reserves of thorium. Then last thing is, if you want, is basically base load power. So if we are trying to have clean energy matrix, in that what we will always be missing is something known as base load power. So you get renewable energy, but renewable energy has a tendency of being available at certain time. For example, sunlight is available in the day but not at night. So that is called intermittency. So to fight that, correct, you need some base load power that can power the industries 24/7. That which can provide this nuclear can provide this energy also. Fine. Then okay, then next, yeah, you can conclude with anything. So basically this is a stage 2, and with stage 3 India can become energy independent is what you can end at it. Then this is the third question that we saw. Mention salient features of mission Drishti. Discuss the imaging techniques used in the satellite launched on 3rd May 2026. Why is it being considered world's first satellite of its kind? Now, this was something that we had discussed in prelims current affairs. Let's see. So what you have to do here is basically, first you have to tell about mission Drishti. What is mission Drishti? So mission Drishti is a Earth observation satellite mission by Bangalore based startup that is called Galaxy Eye. This can be your introduction. Okay, why I am keeping a short introduction? Because it is also asking me salient features of mission Drishti. So that I will mention here. That what are the salient features? What are the salient features of mission Drishti? I can give you an idea what this is. So basically this is a Optosar satellite for Earth observation. Now basically what is this Optosar? Basically it has optical sensors also. Optical sensors are simple, your different cameras. So your camera you usually associate with visible light. Similar pictures you can create using infrared, using other kinds of radiations. So that is optical sensor. Then there is something known as synthetic aperture radar. Okay, synthetic aperture radar. So basically the technique is that you take pictures. Let's say if this is a class, so I have to take a very high resolution picture. Now either I can have a very big lens like the size of this board, or what I can do is I can take close-ups of everybody and every part of the class, and then I can collate it to get a very high resolution picture. Okay, so basically here what is happening, the lens is small enough but it is creating a much bigger aperture. That is why it is called synthetic aperture radar. Now optical sensors, they are usually dependent on light. These are usually passive sensors. So they are dependent on ambient light, sunlight, this, that. Okay, it cannot penetrate through clouds if clouds are covering, let's say, the earth, correct? But synthetic aperture radar, this sends its, because this is an active radar, so it sends its own microwaves, and that is why it can work even in cloudy conditions, even when there is no light. Now what they are doing here in this mission Drishti is they are combining both these, and that is why this is the first time in the world that it is being combined like this, that it is getting the same picture from both these sensors at the same time at the same angle, and that's what makes it unique. Now salient features, now I think you will be able to write. First, this is the heaviest earth observation satellite by our private sector. Okay, this is approx 190 kg. Then it has two kinds of payloads. Now you have understood, one is synthetic aperture radar and the other is multispectral imaging sensors or multispectral optical sensors. Okay, so these are certain special features. You can also mention one thing, that it has edge computing. So basically what it does, that whatever are the observations from this optical sensor or synthetic aperture radar, it fuses them both together right there in the satellite itself. It uses artificial intelligence for it, and it gives you the final output. Okay, so these are the salient features. Now it is asking you discuss the imaging techniques used by the satellite used on this. What are the imaging techniques? Optosar, optical and synthetic aperture radar. Both of these, as I have explained you, this only you have to explain in one line. So how you write this? So basically you write the definition, then you write about that this requires ambient light, this works without ambient light also. Then this is a passive sensor, this is the active sensor, this can work in clouds, this cannot work in clouds. Now, but what advantage this has, that this creates if the light and everything is fine, so it creates very high resolution spectral images. Okay, so this you can mention explaining both of these, what are optical, what are synthetic aperture radars, and the difference between them or both features. Then the last part is, why is it being considered world's first satellite of its kind? So why it is being considered like this, world's first something something. Now here you can make a flowchart, a very simple flowchart that will cover everything here. First is, it does simultaneous observation. Simultaneous observation, that means from the same angle at the same time using optical as well as synthetic aperture radar. Correct. So there have been cases where other satellites have used both of these, but usually what they are doing, it is at different times in different satellites, then they are somehow trying to collate it. Here what is happening, at the same angle, same time you are getting both the images. So this is called simultaneous observation. Then there is something known as on-board fusion. On-board fusion using artificial intelligence. So everything will be fused together and to create a singular image or imaging maps that will have both of these together to create the most accurate information, and then you will get the final output directly. So you will get the more precise final output directly. This is what makes it the world's first real optosar satellite. So this is how you can mention what makes it so unique. Then what you can end this with, why is it being considered? So you can mention that mission Drishti is a great step, or you can mention that mission Drishti is a very good example of success of India opening up the space sector for private organizations also by the space policy 2023, or you can mention here NSIL or InSpace. All of this works. So basically why India opened it up for private sector, and private sector has shown results like this. This is your conclusion. Then last question. Now agentic AI. Okay, many students have written wrong answer for this. Okay, now there are 2-3 terms. There is something known as generative AI, which is used to create content, this that you use, correct, create images, videos that we use LLMs. Now there is something known as agent. What is an AI agent? AI agent is some agent that if you give it prompt that you have to do this task, it will be able to achieve that task. Okay, somehow it will do certain things, it will follow a procedure and get the things done. Now agentic AI is something different. What is agentic AI? Agentic AI is basically you give a very complex task to it. It will break that task down, and after that it will deploy different agents that will work simultaneously, and all those agents will talk to each other. They will decide that now we should be doing this, now these tools I must be using. So they discuss, you can see the discussion also. Okay, if you use the Opus new versions of Claude, you can see their discussions also, what those agents are talking amongst them. And after that they will be doing using all the tools, whatever is needed from the external environment, that also they will use. Then they will do multiple iterations and finally give you the output that you wanted. Okay, for example, I can just type that book me a trip to, let's say, Leh Ladakh, and then it will start and do it from end to end, everything, even recognizing what are my needs and what kind of things needs to be done. Flight has to be booked, hotel has to be booked, everything it will do on its own. That is agentic AI. Okay, now so basically these are agentic AI. This is the definition, this should be your introduction. Agentic AI refers to autonomous systems that can employ multiple agents that can coordinate and achieve complex task without any human inputs. This is what it has to do. Now, because it has a specific question of what is agentic artificial intelligence, you should write a few lines more. So what you can mention here is that unlike generative AI, then you can note down this, whatever I explained you. Unlike generative AI, which can generate something based on the prompt from a human, this can execute things on its own by making decisions on its own. So it can make its own decisions, it can decide what should be used, it can do multiple iterations and then get to the final result. That is executing something. So this you can mention here, so that this part is dealt with decent enough. Then explain its working and describe its application with suitable examples. Now first, working. How does it work? So there are many steps. Okay, for example, first thing that you need is, first thing that it does is basically planning, that is dividing it into subtasks. Here if you know, you can mention react. Okay, react you might have heard, correct? What is this? So basically this is reason plus act. So it has to reason that what I should be doing and act on that. So first is planning, dividing it into subtasks. Then it has to put this in its memory, so that it can break it down, it can refer to it again and again. Then after that it has to identify the tools that will be useful here, or that has to be used here. Now tools may be anything, some code repository, okay, some browser, some software, anything. It has to identify it and then start doing it. So identify the tools that will be useful. Then the next thing that it will do is use even external environment to execute the task using all the tools. This is what it has to do. Then after this is also done, so once the tools and everything is done, then it must do multiple iterations it must do, so as to using different kinds of test cases. If you have done coding, you might know about test cases. So it will test different things. That is this working fine? Is that working fine? Is the result for that particular input is fine? All that it will do. Then it will do self correction and again memorization. Why? Because you can give a similar task again, and then after this it connects back to planning. So if there is some self correction needed, it will come back to planning, dividing it in some different way if needed, and then follow this process again and again and again. This is called an working of agentic AI. Okay, now what is important here is some people will do what? They will do mismanagement of space in this question. Why? Because here you have written what is agentic AI. Now in working they will explain the working for a very long time, but observe that this question is like those some internal security questions you have now, where they ask you a lot of things. So what you have to do in these questions to get good marks is address every section of it. So because now that's why I have done it in very short, this working. After this, not short but in a flowchart form, then I have to discuss advantages. I will write this separately. Even if I have to write 2 points, does not matter, but I will write it separately. Risk and challenges that are associated with agentic AI systems. Now let's start writing all these three separately. First is advantages. What is the advantages? First is that this frees human capital. Correct. So many of the tasks that are repetitive in nature, that this agentic AI can do. Correct. Then next is 24/7 operation. A human being will not work for 24/7, but agentic AIs, they are also doing discussion, this, that, everything that they can do 24/7. This is another advantage that we have. Then next thing is basically it was asking about risk. Okay, now what is the risk with this? So the risk that we always run here is basically of hallucinations. Why? Because like all artificial intelligence, this can also hallucinate, start thinking that I know the input and the output, but really not knowing anything and blabbering anything. So hallucinations are still possible. Then there is some issue with respect to cyber security also. Correct. Then what are the advantage, risk, and now challenges? What are the challenges? Now one of the major challenge is basically of misalignment. What if the goal is misaligned itself? Then it will execute everything, it will not ask you again, and it will execute something wrong. The other thing that you can put is with respect to economy, that is large scale job losses. This is only a probable issue or probable challenge. So this is advantage, risk, and challenges. Now I think applications is also asked. Discuss its advantages, risk, and challenges associated with, describe it application with suitable examples. So here, before writing all this advantage, risk, and challenges, what should be mentioned is its applications. This question is very long, that is why only two points I have written in all these three, but if you write it separately you will get at least a mark extra. Now what are the applications? Applications are in every domain. So basically this can be used in autonomous, just learn this word autonomous and then start putting anything. Autonomous software development, then autonomous research and development. Correct. It can carry out entire researches, give you the final research paper. Then autonomous, okay, if you don't want to use autonomous you can remove it. So basically this can be used in precision medicine development. Correct. Then this can be used in disaster management. it can predict the disasters using all those different variables, and it can also devise plans that can help us mitigate or adapt to disasters. So all these, only 3-4 you write here because you have a very long answer to go, and these 3 you write. Then you can conclude with agentic AI is a very powerful tool, but to ensure that there is responsibility being taken by it. There must be something that we call as human in the loop. Okay, so this must be ensured by regulatory agencies, that while using agentic AI is very good, there must be some human in the loop to ensure accountability. Otherwise, agentic AI can do anything, and then who is to blame or who is to take responsibility? So this you must mention in the conclusion, because there is no space for way forward. They have asked everything. So this you mention in the conclusion. Okay, with this we are done with your discussion of all the 4 questions. Okay, all the 4 questions were very good, as in it was really testing students. So if a student was really good at science and tech, he can score very well in it, and the people who are not so good in it will lose a lot of marks in this. That is why I always say science and tech in mains is a very important decider, that it decides that how good you will be doing in GS3 or not. Okay, with this we end this one. That's it. Thank you.